Let's get started. This is our application running locally. It's a simple Node and Express application that responds to a single endpoint with a JSON message, hello world. Notice that our application is listening on port 8080. This is going to be important later when we set up our container. We also have tests set up, and to run these tests, we run npm test. So let's go ahead and create a repository using AWS code commit so we can push our source code too. On the AWS console, we click on code commit, create repository, give it a repository a name, Node API, click create. Let's click on SSH and select your operating system. And if you haven't yet, you need to add these settings to your SSH configuration. I've done this already, so I'm going to skip it and copy this SSH URL and add it to my Git remote. And now I can push to it. Cool. Once it's pushed, we can refresh our page and see our code is properly uploaded. With that in place, let's go ahead and create our build. To do that, we're going to use code build. So let's go ahead and click on code build, and we can click on create build project. Project name is going to be Node API build. And for the description here, we can say run tests, builds Docker image and pushes to ECR, which will do this later. For the source, we're going to use code commit. We could also use GitHub, but we're going to keep it all in-house for this video. The repository, we select the one that we've created, Node API, select the default branch. And for the environment, we're going to use one of the managed images that AWS provides. For the operating system, we're going to select Amazon Linux 2. And this OS offers a series of built-in runtimes. To see these runtimes, we can click on this link. And for our example, we're going to be using Node.js as the base image to run our build. And we can see here the different versions of Node that this Amazon Linux 2 image supports. So 8, 10, or 12. So let's close this and go back to our build and select the runtime standard. And then the image will be the latest Amazon 2 image. Environment type Linux. Since we're going to be building a Docker image, we need to select privileged. Then leave everything else as is. For the time being, we're going to start just running tests, so we don't need artifacts for now. And we can create the build project. Cool, the build project was created, but before we can start a build, we need to add a build spec file to this project to tell code build what to actually build, what commands we want to run. So let's go ahead and do that now. I'm going to open our project here, create a new file. We're going to paste what we need for this build file, and we're going to call it buildspec.yaml. Now, what this file is saying is that we want to use Node version 12, and the commands that we want to run are npm install to install the project dependencies, and then npm test to run our tests. That's all we need for now. So let's close this, commit our changes, and let's push that to the repo. Let's clear the screen here. With the file added to the repo, we can now run start build. We're going to use all the defaults and then start build. It takes a minute to trigger, so let's just click tail logs and watch the progress. All right, so our build completed with success. We can see our tests were running and everything worked great. Let's close this, and now let's go ahead and start putting it all together using code pipeline. So what we want to do now, we want to automate the process of pushing code to the repository and then triggering a new build. So let's go ahead and go to code pipeline, and we're going to create a pipeline. Give our pipeline a name, Node API pipeline. It's going to create a new service role for us on IAM. Click next. The source provider is going to be code commit, which is what's going to trigger the pipeline, every push to the repository. The repository name that we've created, the branch, and then we're going to leave these as is. Click next. The build provider is going to be code build, and we're going to select the project name that we've already created. Hadn't we done so, we still have the option to click on create project and do it from here. I personally find it a bit confusing, and I much prefer to create the build project beforehand, like we've done. Let's click next, and we're going to skip deploy for now. Remember, the goal for this step is to simply trigger a build after we push the code to the repository. We want to run the tests, and that's it. We're going to leave deploy for later, so we're going to skip deploy stage, review our information, and click create pipeline. So the pipeline is created, and we can see it's already running a release. Should be done in just a few moments. It pulled from the source code repository, and now it's running the build stage. We can click on details to see the log. The first part of our project is done. Every time we push code to our code commit repository, Code Pipeline detects the changes and triggers a new build using code build. Now for the second part, we need to set up a few things. So first, let's create a repository that will store our Docker images. So let's go to Services, Elastic Container Service, and click Repositories. And then we're going to create two repositories. Now, before we create a repository, let's take a look at our Docker file. So let's look at the Docker file for our application. I want to point out this first line here, which pulls the base image from the official Node.js Docker image from Docker Hub. Docker Hub recently implemented a limit on the number of Docker pulls that an anonymous account can run. Now, this means that depending on the number of times that we run the build on AWS, we're going to hit this limit, and then it's going to break our build. Now, one way to get around this is to, instead of using Docker Hub for the source of our base Docker image, is to store this Docker image in our own repository on ECR. And this is what we're going to do right now. So let's close this file and create a repository. It's going to be private, and we're going to name this node. Create repository. And then we're going to create a second repository for our application. It's going to be our Node API. All right, perfect. Two repositories were created. Let's go ahead and push our base image first. So to do that, let's click on the repository that we've created for our base image, and we're going to click on View Push Commands. Now, the way that ECR works is a little bit different than other AWS services. ECR has its own authentication system, and all we have to do is remember to run this command prior to pushing or pulling from the repository. So let's run this command locally so you can see what it means. We are authenticated on ECR. Now let's pull the Node.js image from Docker Hub locally, running Docker pull. I've already pulled this image before, so we don't need to pull anything now. Now we are going to tag this image using this command right here. And instead of latest, let's use 12 and 12. So we've tagged the image, and now we are going to push this image to our repository. Our base image is now published to ECR, so let's refresh the page. And we can see our base image is here. Now we need to replace our Docker file to pull from this base image. So let's click and copy the image URI. Go to our Docker file again. We are going to prepend repo to our image name. Save this, and that should be it. we are going to commit our changes. Cool. Now, before we push again to our repository and trigger another build, we need to add a few more commands to our build spec file. So let's open that file again. Remember, so far, we're simply installing our NPM dependencies and running our tests. What we want to do now is trigger a Docker build to build an image every time we push a change to the repository, and then push this new image to ECR. Now let's add the commands that do that. First, let's write a message, building and tagging Docker image. Now remember, we need to authenticate with ECR. So let's add our authentication command. Next, we are going to run Docker build, tag node API with the current Docker file. Then next, we are going to tag this image with our repository. So this takes care of building the Docker image and tagging it accordingly. Now we want to push this image to ECR. So on the post build phase, we want to print the message pushing to ECR, Docker push to our repository. And that should be it for the building and pushing phase. So let's save this file. Add it to our commit, and then building, build, and push Docker image. Cool, that should be it. Before we trigger a build, let's go ahead and go to code pipeline so we can watch that build once we push it. Cool, so let's do a git push origin master. Wait a few moments for the build to start. And ladies and gentlemen, we have a failure. So let's dig in and try and find out what the failure is. Thanks to CloudWatch, we can look at the logs, scroll down, and then we'll find that the code build service role is not authorized to perform this specific action. Now we need to add one policy to the code build service role on IAM. IAM stands for Identity and Access Management, which is where AWS groups everything related to authentication and authorization. Now let's find our service role for code build. There you go. Now I'm not sure which one of these two, so let's go back to the log just to be sure. So this is what we're looking for. Let's just copy this just in case. And this is the one. Now we need to attach a policy that allows us to do that action. And the policy in question is called EC2 Container Registry Power User. It's this one. If we expand this policy, we can see that it includes the action that we need, get authorization token, and a few more that are probably used by that step. So let's attach this policy to the service role. It's attached. We're going to close this, and we're going to run our build again. Go back to the pipeline and click on retry. And our build succeeded now. Let's go and check our ECR repository to make sure that our latest image is pushed. Repositories. And the Node API image is there. Cool, that worked. Now the second part of our project is done. Now let's move to the third and final part of our project, which is actually deploying our application. Before we do that, we need to set up the environment. So let's go ahead and click on clusters. We're going to create an ECS cluster. To do that, we're going to click create cluster. we're going to select this EC2 Linux plus networking option, click next step. Cluster name is going to be Node API. For now, we're going to use on-demand instances, and we don't need an instance this large. Let's use a T3A medium. The number of instances that we need are going to be 2. The way that this works is the cluster is going to create and manage EC2 instances for us. And in order for the CD part to work, we're going to have one application always running in one instance, and another instance is going to be idle. Once the deploy stage kicks in, the deployment agent is going to look at the idle instance, is going to start a new task on that instance, and then once that task is running, it's going to shut down the previous task on the other instance. This would not work if we had a single instance. So that's why we need at least 2 instances for this to work. Now we're going to leave all these other options as default and click on create. Perfect. Our cluster was successfully created. Click on view cluster. We can see that we have our Node API cluster created, but so far no services, no tasks, no container instances or anything. Now we can check and see that we have EC2 instances running. If we go to EC2 and then instances, we can see that we have 2 instances running and that are managed by ECS. Now let's go back to our cluster, and before we can actually start our application, we have to create task definitions. These task definitions will indicate which container image we want to run and what settings will be applied to that task. Create new task definition. We're going to select EC2. Next, task definition name is going to be Node API. For the task role, we're going to select this one. Leave the default network mode. Task execution role, select ECS task execution role. Leave these blank, and this is where we add our container. Click on add container. For container name, Node API, and this is where we're going to use the URL of our ECR repository. We need to set a hard limit, and for the port mappings, this is where we're going to say that the host port on our EC2 instance, port 80, will map to the container port 88. Remember, when we run our Docker container, the application loads from port 8080. So we need to add this mapping here in order to make it work with the default HTTP port 80. We can leave all these other options blank and just click add. Perfect. Our container was added. We can scroll down here, click create. And notice it says here Node API 20. And this is because I've done this workflow previously. And each time I create a new task, it creates a new revision. And there's no way to reset the revision. Yeah, and I've done this 19 times on this region alone. Now with our task definition ready, we go back to our clusters and we can start a service now. Click on our cluster again, and we create a service. Select EC2, service name, Node API, number of tasks 1, because we only need 1 container running at a time. Leave these other options as is. Click next step, no load balancer for now. Click next, next, and then create service. Service was created. Let's look at our service details. Click on the refresh button here. We can see the progress still pending. We can see that the desired count is 1 and pending count is still 1. We don't have any running services yet. Click refresh a few times, and now our service is running. So let's click on this task here to expand the details. And then if we click on external link, boom. So we have everything we need set up on ECS, and now we can tie it all together by adding a few more lines to our build spec file. So let's open our project again. Open our build spec file. And we need to add a image definitions file, which will tell ECS exactly which task to run upon each deployment. Now I'm going to use printf to print a JSON into this image definitions.json. And once we do that, we have to declare here at the end that we have artifacts. These are files, and the file is image definitions.json. Behind the scenes, AWS uses an S3 bucket to store this file at the end of the build phase and then read from this file again during the deployment phase. Now let's save this file. Before we push to a repository, let's add a deploy stage. To do that, we click on Edit, Add Stage. Let's call this Deploy. And then we can add an action group. Call this Deploy as well. Action provider is going to be Amazon ECS. The input artifacts we're going to read from our build stage. The cluster name is the cluster node API, which we've created. The service name is node API as well. Image definitions file is the image definitions.json. And that's all we need. Click done. Click save. But the deploy didn't run yet. So let's go ahead and run this with a push to the repository. Let's go ahead and make some changes. Let's change the message that we're printing. And instead of hello world, we want to say hello odevs. Practicing TDD, we're going to run npm test. Our test will fail. We go to our app file, change hello world to odevs. Run our test again. Tests are passing. We're going to add our two new files, change message, and let's push to our repository. Cool. Code is pushed. Let's clear the screen, close our project, and wait until the build is triggered. We can see the pipeline is triggered, the source stage completed successfully, and we're running the build stage. The build stage takes a minute, and now we move on to the deploy stage. Let's click on details to see what's going on. Notice here we have a new deployment ID and a pending count here at the top. We click on refresh. We can now see that we have 2 running counts. And that's because it takes a minute for ECS to shut down the older instance. In the meantime, we can click on task and see that we have both of them running. So if you click on this one, this is our new deployment, which should have our new message. Yep, hello odevs. And if we go back real quick, we can still see the previous deployment, if we're quick enough. Hello world. Now this one is going to be shut down by ECS at any minute, and it's offline. So now our current deployment is this one, hello odevs, and our project is complete.